Okay. So this is matrices, section 7.2. And one of the things that we need to know about matrices is the dimension of the matrix. For example, here you have this array of numbers. It says, let m and n be positive integers. An m by n matrix is a rectangular array of m rows. So here we're talking about this is 1, 2, 3, 4, 5. This is the m, and n is the columns of real numbers. So it's column 1, 2, 3, 4, and so on this way. Okay, so it's an m by n number of rows. And so an m number of rows times n number of columns. Now we also use the shorthand notation as just, that symbol A. That's matrix A for this matrix. Now, second part. The vocabulary. Each element or entry, it's considered as an A, I, and J. Sub I, sub J is, in this case, the location of the entry. In this case, for example, it says, the matrices uses double subscript notation. The row subscript is the first subscript, which is the I. The column subscript is the J. The element A sub I sub J is the ith row and the jth column. In general, the order of an m by n matrix is m times n. Now, talking about A, let me just give you a little example of that. For example, if I have a matrix, let me just put numbers, okay? 4, 3, 2, 1, 1, 2, 0, 1, 4, negative 1, 0, negative 8. And if I ask you, okay, give me the element, give me the element in which I want, what is A, 2, 3? What is A, 2, 3 equals to? Okay, in that case, the 2 is representing the I, okay, which is, if you look at this example right here, let me just underline that. I is a row, and J is a column. So this is a row, and this is the column, okay? So have you heard about that soda that used to be in our old times? My old times. RC.
I love that soda.
Yes. Okay. Well, don't forget that soda, because that soda, the RC, gives you the order in which is given. The first number is the row, and the second number is the column. So if they tell me second row, this is the second row right here. Third column, 1, 2, 3 columns. So second row, third column, what is that? That is 0. So the answer here is 0. Okay? So that's the location.
I'm ready.
You ready? Okay. Okay, so tell me, what is A 4 3 1? 3 1. A 3 1.
Okay, so the
What is that equals to?
4. Positive.
Is it 4? Okay. 1, 2, third row, first column. It is. That's 4. You're right. Okay, God bless you. So that RC is a location of an element. Okay, so each one of the elements is considered an entry in the matrix. That's what the subscript I represents and the J represents. Okay?
So I is the row, right?
That is right.
Okay,
And J
is column.
is a column number. That is right. Okay. So here it says, what is the order of the following matrix? Okay, when you give the order of a matrix, the order is an M by N. M, they explained here, M is the rows, N is a column. So when you give an M by N, I need to know how many rows I have and how many columns I have. Okay? So it's how many rows? It's 2 rows, okay. So it's a 2 because it's 2 rows, and then it's 3 columns. So it's a 2 by 3 order.
And that's how you put in the answer?
That would be, yeah, that would be the answer. Just like that. Yes. Okay, so that's the order of the matrix. That's what? Anyway, yeah. Good. I like that. Okay. Next example. Now let's move on to adding matrices. Okay. When you add matrices, look at that. I've never seen that before. And all those, yes. Okay. My excitement about technology. Okay. Adding. When you add matrices, you gotta have the same number of rows and the same number of columns. Okay. So for adding and subtracting, you have to have that. When you multiply, it doesn't really, go with that, the same number. When you multiply it, there's another rule. But let me just go with the addition and the subtraction. For the addition and the subtraction, all you have to do is you add the same row, the same column. So here, like the 1 with the 2, because it's the same row and the same column. So when we add the matrices, you're just going to go, okay, this is 1 plus 2. And then on the second one, I'm going to go with the second one. Okay. Well, that is the same thing as 2 plus 3. I'm just rewriting everything. Later on, we don't have to do that. Just to make sure that we understand. Then 3 plus 4. Then on the second row, first column, 4 plus 5. Second row, second column, 5 plus 6. Second row, third column, 6 plus 7. And then once you do that, you just simplify. So your answer is 3, 5, 7, 9, 11, and 13.
Ooh.
And that's the answer. Nice, right?
Are we in calculators on this?
You like that?
Oh,
guys,
what if they're not even?
Ah, this is so easy, right?
What if they're not even?
Yeah.
Miss, give us the test.
No. I'm not joking.
Not yet, not yet.
Not
Okay.
yet, not yet.
No. Okay. What if
You're doing it wrong.
instead of a plus we have a minus? Okay, so now
Subtract.
we just subtract. Same thing, but we just subtract.
But
So let me just do it like that. When you subtract, the same thing. Okay, you gotta have the same entries. You subtract the entries. Okay, so the answer for the subtraction would be what? Negative 1, negative 1, negative 1. Everybody okay so far?
Negative 1.
Wait, miss, oh, you're subtracting.
We're just subtracting, right? I'm using the same matrices, but with the
They're
subtraction.
all negative 1.
They're all negative ones, right?
Yeah.
Really?
Is that by
Yep.
coincidence?
Oh, yeah.
Or?
Yeah, it's just by coincidence. So they're all negative ones. You got the idea?
That's if you subtract.
That if you subtract, yes. Okay, so that is addition and subtraction. Now let's go with the multiplication. In matrices, multiplication is called scalar multiplication, okay? Because it's like a scale factor that you use. So that scale factor, that means that whenever it's a scale factor, that means multiplication, okay? So all you're going to do is distribute each one of the entries by that scalar factor. So here, that's all you got to do. Just multiply 3 times each one of the entries. So 3 times 1, it's 3. 3 times 2 is 6. 3 times 3 is 9.
Or you just distribute it.
That is correct. You just distribute that scalar number with all the entries inside the matrix. And that's the answer. Kind of easy, right?
Yeah.
I think so. Okay. Now, what if, we have a combination of addition and subtraction and multiplication? Okay. Let me just add that.
Here we go.
Here we go.
This is where
I'm going to make the scalar factor to be negative 2.
Don't do this.
I'm going to use same matrix, 1, 2, 3, 4, 5, 6. And I'm going to add it to another matrix.
Oh, okay. I think I know what to do. Ask me.
Good. So at this point, you first multiply, and then you add or subtract. Just like, please excuse my dear Sally.
You do the
Okay.
canvas, right?
Yeah.
That is right. That's another way of, yeah. You distribute first. So when you distribute, you're going to have -2, -4, -6, -8, -10, and -12. Once you have that distribute, then you combine it to the second matrix. So the final answer here,
How does it get you don't check out the same like bottom rows or?
we have the same number of rows and the same number of columns, right? So we just combine same row with same column number. So here, when you combine -2 with 6, -2 with 6,
4.
that is 4. -4 with 5,
1.
1, -6, and -2.
-8.
-8, -8, and 4.
-4.
-4, -10, and -3.
-13.
And last one, -12 with +8. -4. And that would be the final answer. This would be 2 times a matrix plus another matrix. Now, the only difference that you could have here is that maybe it's not an addition, it's a subtraction minus a matrix. So if it's a minus a matrix, then just be careful. Because like for something like this, it would be like -2 minus 6, and that would be -8. -4 minus 5, so you distribute that negative with each one of them before you combine it with the previous, with the first matrix. Yes, Alex?
What if there's not like
Now, the next item is matrix multiplication. When you multiply matrices, the order, for example, here, what's the order of the A matrix? It's a 2 by 3. Okay. What is the order of the B matrix? It's a 3 by 2, right? In order for you to multiply two matrices, you have to have the same inside numbers. Okay? You need to have these two the same. If these are the same, then the order of the multiplication would be the outside numbers. Okay, so just, before you multiply, double check that that is possible. So now, once you check that, you can, okay, let's go ahead and move on. Let's multiply now. Now, what you need to do is you need to get your row multiplied by your column on this side. So you're going to multiply row by column, row by column. Second row, first column, second row, second column. You multiply them like that, okay? So let's go ahead and multiply. It says here, get the product of A times B. So this is the work. AB equals.
1? Oh, sorry.
Okay, so let's multiply. I'm going to put all the numbers and then we just simplify that, okay? So 1 times 1 and then plus 2 times 2 plus 3 times 0. Okay, now let's do the same thing, but now with the second column. Okay, now we're going to do first row
0 times 2.
1 times 0
Oh.
Why?
plus first row times second column. Okay, now 2 times 1
Wait a minute, where did you get the 1 times 0?
by first row, second column, because I already multiplied the first row times the first column.
Oh, so you have to do that for this second column.
Right. So you do row times first column, row times second column. Okay? So notice that these two, if I were to overlap these two, this would be the location. First row, first column. So that's the intersection. First row, second column, first row, second column, that's the intersection. So that's where I need to put the answer, the product of that. Okay? So now let me continue. So I did 1 times 0, 2 times 1, and now 3 times -1 plus 3 times -1. Now let me just close up this right here. Next, I'm going to go ahead and multiply. I'm going to multiply second row, first column, okay, like that. So 0 times 1, and then is 1 times 2, and then negative 1 times 0. Now the next one,
2, 0 with the second column.
that's right. Now second row, second column. So it's 0 times 0, then is 1 times 1, plus negative 1 times negative 1. Let me move that a little bit this way.
And simplify all that down here?
Yes, so it's negative 1 times negative 1. Now all I have to do is just simplify that. Okay, so AB equals, now let me just simplify that. Negative 1 times 1, that is 1 plus 4 plus 0, right? When you multiply these numbers here. 1 times 1 is 1, 2 times 2 is 4, 3 times 0 is 0. Now the next one, that would be 0, because 1 times 0 is 0, 0, 2, and then negative 3, because 3 times negative 1 is negative 3. And now 0 times 1 is 0, 1 times 2 is 2, negative 1 times 0 would be 0. 0 times 0 is 0, 1 times 1 is 1, negative 1 times negative 1 is positive 1. Now let me just simplify that. 1 plus 4 plus 0 is 5. 2 and negative 3, negative 1. On the next one is 2, and then is 2. And that's the final answer. Do you notice that the product was a 2 by 2, and this is a 2 by 2? Okay, so what I've mentioned to you is that if the inside numbers are the same, go ahead and get the product,
Sort of like oil?
because you will get the answer. And the solution should have an order of a 2 by 2, and this is a 2 row, 2 column matrix, so that's the answer. Okay? Any questions about multiplication, matrix multiplication? So far, so good? Okay, now let's go ahead and, what did I do? Wow, that was nice, right? Okay. Now, the next concept is the identity matrix. The identity matrix is the matrix where all the numbers, all the entries on a diagonal are ones, and the remaining numbers, the remaining entries would be zeros. Okay, so this is an identity matrix.
So then that's just, if you figure out, like one of the questions just says 1, like straight down, or any numbers?
Is it an identity matrix? That's an identity matrix. It's a diagonal of ones, all the rest of the entries would be zeros, yes.
Okay.
Now, the next concept is inverse of a square matrix. Okay, it says, let A be A sub I and J, be an N by N. So it's the same number, I and I matrix. So that's like a square matrix, because it's the same thing. Nicole, there's nothing online. Are you using the iPad? Okay. Please. If there is a matrix B such that AB equals to B times A, and that is equals to the I, then B is the inverse of A. So if you happen to multiply A times B, and your answer is the same thing as B times A when you switch it around, and your answer is an identity matrix, then that means that A and B are inverses of each other.
So it's a good thing.
That's how you identify when matrices are inverses of each other. If their product is equals to the identity, then they're inverses of each other. And sometimes they're going to ask you, are these two matrices inverses of each other? And what are we going to do? Multiply both of them. And if our answer is the identity matrix, then you're going to say, yes, they are.
And so what's the identity matrix?
The identity matrix is a matrix that has an
Oh, yeah,
error,
that.
a diagonal of ones, and the remaining of the entries are
So even if it's
zeros.
like 2 1